All right, so moving on with the momentum principle, what we want to be able to do with it is to predict the future, namely future position and future motion. So we can do this because we know that the change in momentum is equal to the final momentum minus the initial momentum, and we know that change in momentum is equal to F net delta t. Therefore, final momentum is equal to initial momentum plus F net delta t. Also, you might see this written as future momentum plus, or is equal to the momentum of the now plus F net delta t. So this is a common convention used for the iterative method in your book, but these are identical, just different subscripts. Let's see how we can use this to go after what we want. And it'll also give you a feel just how powerful the momentum principle really is. Okay, so let's think through a situation. We have a skydiver who jumps out of an airplane. So when they first jump out, they're going to be accelerating faster, and you're going to have the force of gravity pulling them down, and you're going to have a little bit of air resistance pushing back up. They continue to fall, and then the force of gravity is still pulling them down with the same amount, and now air resistance is going to get a little bit faster. And then we will get to a point where the force of gravity is going to be the same magnitude as the air resistance that's pushing them up. So gravity pulling them down, air resistance pulling this up. It'll be helped because at some point the parachuter is going to release his parachute, thus increasing the total air resistance. All right, so why exactly? So F net in this case equals 0. So what exactly is going to happen next? Would the parachuter float without moving up or down? Would he continue to fall faster and faster and faster, or would she fall at constant speed? Well, let's reason through this using the momentum principle. So what we're after is we're after future momentum. And we know that this will depend on the momentum of the now and the net force of the now times delta t. Now, in this particular case, we know that F net is equal to 0. So it doesn't matter what time interval we look at, that's going to imply that this is equal to 0. So we need to think about what P now is. So P now is equal to mass times velocity. So before these two forces were equal, this person was falling with some velocity and they have some mass. So the mass is not 0 and the velocity is not 0. Therefore, they will fall at constant speed. Because their future momentum is determinant on both of these things. So if this is non-zero, then this will be non-zero. Likewise, if this is non-zero, then this will be non-zero. All right. And all of this is, of course, leading us to a calculation known as the iterative method, which will be introduced in the next section.